Hey everyone, and welcome to the quadratic solving mixed practice. So here we're going to get to see a bunch of different strategies for solving quadratics mixed together and needing to kind of understand when to use each. So first thing I'm kind of noting is that we should have these set equal to 0 so that I actually have something to solve. Okay, it looks like those are the only two that I missed that on. So for solving, it's often going to come down to practice, figuring out what strategy that we should use, but I'll try to highlight my thinking along the way. So for this first problem, the 4x squared minus 50 equals 14, I don't have an x squared and an x term. So generally that means that I can just solve this using a traditional equation solving strategy. So this would be 4x squared is 64. Divide both sides by 4. X squared equals 16. Square root both sides. And I get plus or minus 4. So I don't need to do any factoring unless I do have like an x squared and an x term. That's generally a good indication as to when I need to do that. Here for our second problem, which is x squared minus 11x plus 24, I do have an x squared and an x term. I don't have any common factors here, so I should just be able to try factoring this straight away. So that's what two numbers are multiplying to positive 24, but add together to give me negative 11. So I'm thinking 3 or negative 3 and negative 8 will multiply together to give me 24 and add to negative 11. Then I'm going to solve each of these little mini equations. So this equals 0. When does this equal 0? And then here I would just add 3 to both sides, and here I add 8 to both sides. So I end up with these two answers. All right, my third question, I have an x squared and an x, so I'm going to need to factor. Whenever factoring, whenever you need to factor, you always want to take out the common factor first. So here, each of these is going to be divisible by 3. So I can take a 3 out of each, and I end up with this expression. Now I have something that I can just straightforward factor. So I'm saying what multiplies to 3, but adds together to give me negative 4. And I have negative 3 and negative 1 will take care of that for me. Solving these factored mini equations set equal to 0, I'm going to get 3 and 1. Here, I have an x squared and an x, so I definitely want to make sure to factor. And I have some common factors between these two, so I'm going to take 9x out of both, and I would be left with this when I'm done. So confirm that for yourself by distributing that if you needed to. 9x times x is 9x squared. 9x times negative 2 gives me that negative 18x. And then I have two things being multiplied together to equal 0. So I'm going with my little mini equation strategy. And for this one, eventually we'll probably fast forward and just say, oh, I know it's 0. But just to show you that, I still set it equal to 0. And then I'm still solving. But if I have x all by itself in factored form, then I'm just going to get x equals 0 for one of those answers. Okay. Here, I don't have an x term, so I'm going to attempt to at least just solve this traditionally. So I have negative 4x squared equals 16. Divide both sides by negative 4. X squared equals negative 4. I can try to square root both sides, but we'll realize that our calculator is going to give us an answer. And that's just because this has no solutions. Okay, so algebraically, if I arrive at something that is impossible to solve, then that just means that this quadratic has no solutions. I can't find any number for x such that this side is going to equal 0. So it has no answers. All right, I've got 6n squared plus 5n minus 6. I have an n squared term and an n term, so that means I'm going to need to factor. I don't have any common factors, so this is where we do like that as intricate as it gets strategy. So I'm going to do a times c, which gives me negative 36, trying to get to my b value, which is a 5, and let's see what I can come up with for my factors. So for factors here, sorry for that little zoom in out, I have 1 and 36, 2 and 18, 3 and 12, none of that, and then I've got 4 and 9. So 4 and 9 looks good. As long as I have a positive 9 and a negative 4, that will add me to 5. I'm going to zoom back in. Sorry, folks. Okay, I want that 9 to go with this 6n squared. So I'm going to say 6n squared plus 9n minus 4n minus 6 equals 0. Right? So all we did was we split this 5n into whatever answers that I got on the right-hand side. So I got positive 9 and minus 4. So that's going to be a plus 9n minus 4n. And then taking out everything I can that's common between these. So in the beginning here, I can take a 3n out, and I will be left with 2n plus 3. In the second expression, I can take a negative 2 out, and I will also be left with 2n plus 3. Now I know I can take 2n plus 3 out of both, and this is going to become 3n minus 2 equals 0. I'm going to set both of these equal to 0 and solve them separately. And I might just shortcut that to negative 3 halves. And this is going to give me 2/3 over here. All right, well, with quadratics, I need to make sure everything is set equal to 0 first before I probably try to solve. So I'm going to minus 4x from both sides. And just because I'm so crazy, I'm going to add this 3 to both sides at that same time. So I have 6x squared plus 37x plus 6 equals 0. I have an x squared and an x, so I need to factor. I don't have any common values that I can take out of this. So I'm just going to start by saying, okay, 6 times 6 is 36. That's my a times c. My b value is a 37. And I don't need to think too hard on my factors here because 1 and 36 is going to work out for me. So I'm going to break apart this 37x into plus 36x plus 1x plus 6 equals 0. In my first two terms, I can take a 6x out, and I'll be left with x plus 6. And then this is kind of a little bit annoying to factor, but if I take a 1 out of those, then I would be left with this. It's not super common that we do that, but visually it works for factor by grouping because I create those x plus 6's, which is what I'm trying to do. And then I get 6x plus 1 equals 0. Solving both of these, I'm going to get negative 6 from here. And you can trust me on this, we'll get negative 1/6 from this. So set it equal to 0 and solve, and I get there. Similar to our last problem, I'm not set equal to 0 first. So I'm going to minus x squared minus 7, minus x squared minus 7 from both sides. That's going to give me 2x squared plus 7x minus 7 equals 0. I can't combine these, so the other minus 7 just gets tacked on to the end. I have to factor, and I have no common factors right now, so I'm going to do a times c. My b value is a 7. So my factors of 14 are 1 and 14, 7 and 3, or sorry, 7 and 2. And then I'm not seeing that this one actually factors. So this might need to, I might need to make an adjustment on this one unless I'm screwing something up, which I don't think that I am, or if I'm forgetting a factor, which I also don't think I am. So this one actually might be unsolvable. I might need to take a look at this, or it's just unsolvable by factoring, which means that it's a little bit more complicated. So for this last problem, I'll probably make a note of it and or change it before you folks see it, but we can't solve that last one. All right, so hopefully the first kind of 7 on here made sense, and I'll take a look at that last one and try to fix it up for us. All right, thanks folks.